Okay, this is our Ruyer reading group, continuing our reading of Cybernetics and the Origin of Information. We're picking up from page 105 of the translation. This chapter that we're in now, chapter 6, he's explaining his distinction between negative anti-chance and positive anti-chance. So we've been going through some, he gives us a series of different examples to sort of explain these concepts. So anti-chance in general is just, phenomena that are sort of a priori unlikely to happen, the occurrence of these kinds of phenomena. So you could think of, the most basic example would be like you find a coin on the sidewalk and you're interested in whether this coin is fair or not, and you flip it 1,000 times. You're very patient in studying this question, and the coin comes up heads 1,000 times in a row. Most of us, I think, in that situation would conclude that this was not just the sort of freak accident that the fair coin had happened to come up heads 1,000 times in a row. It's actually something to do with the coin itself. There's some property of this coin that makes it come up heads much more often than tails. So we have this anti-chance. It's just the fact that the coin came up heads 1,000 times in a row. And then the question is, what property of the coin or of the whole situation of the coin flip is making this unlikely event come about. So he points to the role of a connection, or this is just sort of his general term for some sort of physical system or mechanism or general sort of property of the situation that makes the event that would seem to be unlikely much more likely to happen. So you can think of sometimes you have like a cable or a lever or something inside a machine that ensures that a certain part can only move in a certain direction, whereas if that cable or lever or whatever it was is not there, or it had not been present, then the part might have moved in many other ways, and that one particular trajectory of movement would be very unlikely to happen. So this sort of connection is just sort of like the general term that he uses here for any sort of physical arrangement in a system that restricts the possible development of the system to this one or limited set of trajectories of development, rather than allowing it to develop in many other ways that would have been possible without that connection. And so he looks at these sort of relatively simple physical systems, and then also about like chemical bonds as an example of this kind of connection, so that you can look at, for example, the different elements and the arrangements of electrons that make up the different shells of the atoms of these elements, and based on these structures of these atoms, you can predict what types of bonds between these atoms are possible. You can say that this element can bond with this other element and produce a compound, whereas these this other pair of elements can't form a compound, and so this is like sort of the basic form of what chemistry is doing, that you can sort of look at the properties of these component elements or these component atoms and figure out what whether they can bond, what the properties of that compound substance are going to be, etc. But he wants to distinguish this kind of case where you have these like sort of these kinds of like construction of a system through the properties of the components of that system, where you sort of connect the components in a certain way to bring about something that would seemingly be unlikely. So this is sort of like the one model. It's sort of like the machine model. But then what he wants to sort of point to is the fact that the construction of one of these machines is itself something that is not explicable in terms of machines, and he's specifically thinking about biological systems. So you have like within a living organism, there are many sort of biological machines. You have an example that I've used a few times before is that in the cell membrane you have little molecular pumps that pump ions or other substances across the membrane. So these are like comparable to the kinds of pumps that we build as machines. So you have a little biological machine that transfers a certain type of ion across this membrane. But the whole sort of process by means of which the organism develops all these cells with these membranes is not itself sort of a machine. So you start from this embryo that is largely undifferentiated, and then the process through which the embryo takes on differentiation and sort of builds its own machines is not itself a machine. And so this is sort of the distinction that he wants to point towards, is that like the presence of these machines, whether it's a biological machine or the machines that we build, or any other type of machine, that sort of presence of machines is not itself explicable in terms of machines, or at least there may be sort of like a few steps you can go where it's like this machine is the product of this other machine, but if you just sort of keep tracing that chain backwards, you can only go a certain number of steps where with a machine produced by a machine, and then at some point you have to get to something that is not a machine, that is sort of bringing about the production of machines. So yeah, that's sort of like the overall argument that he's presenting in this chapter and the book as a whole. So yeah, let's pick up from page 105. Yeah, maybe Angus, if you'd like to read from. I think we're at the image of filling a container, if I'm not mistaken.
Yeah, I can read. One thing I just want to mention briefly, I just mentioned is I was reading a bit about intrinsically disordered. So like on kind of the classic model of the understanding of the way gene transcription translation works. The end of the translation process is a protein, a structured protein, the function of which is completely determined by its structure. But apparently a large percentage of the proteome is composed of at least partially disordered proteins, intrinsically disordered. So like they are built to be, to a greater or lesser extent, unstructured. And their absence of structuration is very important. The way that large numbers of these proteins act together in concert for various complex signaling and transcription related functions. I think that given Ruyer's general emphasis on structuration as opposed to finished structure or function structure, and his argument that, for instance, behavior is partly structured, also significantly unstructured, have found stuff like this and a lot of other developments in biology pretty interesting.
Yeah, that's an interesting point. Yeah, before we just get into the reading. Yeah, I think I think I made this comparison before, but if we think about like a cell, like within an organism, as like sort of analogous to a factory that is producing proteins or various other chemicals. If we were to set up a factory that we were like a biotech company or whatever, we're going to produce all these proteins, like we would organize it. You'd have like, okay, this workshop is producing this protein, and this is the plan to produce. Here's like the blueprints of the technology that we're using to develop this protein, and like here's the person who's in charge, and everything. Like we would have this structure that would sort of break down the process of producing all these proteins into these like sort of component parts. But when you look at how a cell in a human body or any other animal or other organism works, it's like completely different than that. You have like this protein gets turned into this other protein, and then like the rate of production of this second protein and like feeds back to the production of the first one, and it's this like huge tangled web of like processes that are all sort of regulating each other in this incomprehensible manner. So yeah, it's definitely not anything like anyone would like. If you tried to build a factory that worked this way, it would just be like pure chaos.
Yeah, absolutely. Okay, I'll go ahead and read. The image of filling a container with non-deformable balls. So he's talking about the models of the atom kind of solar system. Why he thinks that not always adequate for explaining the kind of self-structure of the atom. The image of filling a container with non-deformable balls only becomes relatively true for the assemblies of ions determining the structure of crystals and the phenomenon called coordination. To study the different types of coordination, the image of a ball surrounded by other balls, either of the same diameter as the first or increasingly larger, is usable and fruitful. One can successively arrange, according to their relative diameter, 12, 8, 6, or 4 peripheral balls around the central. But this type of structure is of a derivative in superficial order. Ionic bonds do not constitute duals, but only crystals. On the other hand, the ionic bond taken in itself and not in terms of the coordinations obviously cannot be explained in turn by phenomena of filling according to simple laws. In contemporary theories of bonding, we clearly reach with structural explanation. Explanation by structure presupposes a whole grammar, space, distance, proximity, individual particles, continuity, and which is inapplicable to structural explanation. The atom is a structuring action, not a functioning structure. Structural explanation gradually and certainly reach the crystalline scale and already partially at the molecular scale. It is indeed true, for example, that in the water molecule, two hydrogen atoms form with the oxygen atom an angle slightly greater than 90 degrees, and that this geometric angle explains certain properties of the water molecule. But the structuring action of the atom itself obviously cannot be understood by yet another spatial structure under pain of a vicious circle. This action requires a red integration of type that can only be conceived on the model of memory invention. An organism also partially according to its structure, but its very structure obviously not a function to a structure. Quote unquote differentiate cannot be reduced to a quote functioning accord differences, unquote, which by hypothesis are not yet present in space. In this respect, the fundamental entities of microphysics resemble organisms. An atom is not like a self-distribution system or a mechanism at our scale, whether made by humans or not. Under the influence of Gestalt theory, it is often still believed that there is no middle ground between a kinetic mechanism with sliders and a Gestalt. It is believed that every structure is necessarily one or the other. This classification precisely misses the most central in a case, which is that of a structure formed according to a transspatial type in hypergeometric ones, whose model can only be found in the action of a conscious and the structure of the atom, quote unquote, arrives in space according to abstract compatibilities or incompatibilities, irreducible to step by step.
Where I read the Gestalt theory, I read it in the structure of behavior, right? By in the beginning, in the theory of reflexivity, right? But I don't know what is Gestalt theory. Gestalt, what is Gestalt theory? That's because I read it in the premises of the structure of behavior, I guess.
Yeah, so I can do like a sort of quick recap here. So in the structure of behavior, it was Gestalt psychology was one of the sort of key reference points that he's sort of working with. So this was a school or sort of approach to psychology that developed like around the turn of the 20th century. That was a sort of reaction against a sort of atomistic conception of psychology. So and there's sort of different forms that this like atomistic approach to psychology can take, but like in general the idea is that you sort of start with like simple components and sort of connect them to each other in one way or another, and then out of the sort of and then you sort of build more complex components. Is kind of like a Lego block conception of psychology, that you just start from these blocks and you just keep putting them together in certain ways, and then as you sort of build more and more complex components, you eventually sort of reconstruct the mind as a whole just out of like combining these components. And then Gestalt theory, so in opposition to this sort of atomistic kind of like bottom-up conception of psychology, proposed, I guess, a holistic approach to psychology where there would be this sort of like general structure of a situation or of some sort of psychological phenomenon that would not be reducible to these sort of components that would combine together to form it. So one area in particular that they were interested in was like visual perception, and the fact that you can sort of maybe a better example to start with would be one of the first examples that that Gestalt psychology looked at was the perception of a melody, where you can recognize a melody, like a simple melody, Happy Birthday or Twinkle Twinkle Little Star, or whatever. You can recognize this no matter what pitch it starts on, what tone you start the melody on. So you can recognize that it's actually the same melody, even if each individual note is a completely different note than in the previous instance of that melody. So it's not the case that you're sort of starting from the perception of one individual note and then sort of combining it with the next and sort of building up the perception or sorry, the sort of recognition of this melody by like, this atomic set of notes that are then combined with each other in some way. You're actually grasping a kind of structure of a melody, of this specific melody as such, and then sort of recognizing that this general structure of the melody is implemented using a particular sequence of notes. And so it's a much more sort of top-down approach to psychology. So in this case, recognition of a melody. But yeah, so in general, just sort of like treating psychological phenomena as structured in this sort of holistic way where you start from the whole structure and then find, how those like overall structures get implemented in terms of specific types of elements rather than starting from the elements and trying to build up to the whole structure. And so both Merleau-Ponty and Ruyer are very interested in Gestalt psychology, but they both think that it's kind of not really going far enough. It's kind of still limited to what actually exists in physical space, and for Ruyer in particular, he thinks we need to get beyond these sort of physical interactions of the different parts of a system, and get to this, what he's calling here, sort of hypergeometrical, or this sort of recognition of a theme or a melody as something that is outside space that sort of can be actualized in space. And so that's sort of like the general, and I think that description probably applies to some extent to Merleau-Ponty as well. But in both cases, they're sort of criticizing Gestalt psychology for not going far enough in sort of moving away from the atomic conception of psychology.
Yeah, thanks.
I can go ahead and read the first page or so of the next section since last time.
Yeah, I think that's good. Thanks.
Detour. In any individualized domain of mechanics, in any domain of primary connections where the individuality of the constituents is partly lost in the individuality of the system, experience reveals behaviors similar to those allowed in psychoorganic individualities by the existence of fields of consciousness with absolute survey. A particularly clear case is that of detour. Let us consider three cases. A. In the bed of a dried up river, a rock has fallen, creating an obstacle. The rains refill the stream. The water takes a detour and goes around the rock. This is clearly only a pseudo detour. The mass of water flows blindly and digs a detour channel by the effect of ordinary physical laws. B. A seemingly very different case is that of dynamic detour. In a magnetic or gravitational field, trajectories are curved as if an attractive or repulsive center were exercising action at a distance, but the situation is the same as the water in the torrent. The bodies describing the trajectories go nowhere. They obey, step by step, the quote-unquote molar dynamics of the field. Actually, water molecules do not come into contact with silica molecules of the rock either. They're dynamically repelled. C. A water supply pipeline in a mountainous region can use the laws of hydrostatics to elevations, provided that the endpoint is at the same level as the starting point. Each siphon or U-shaped part constitutes a detour, which is also only a pseudo-detour combining kinematic and dynamic detours. Here also, the mass of water blindly obeys the laws of D. In an animal, finding an obstacle in its path does not run into it. It turns aside in advance to avoid it, and then resumes its course toward its goal. This is obviously the only genuine, but let us see what it presupposes. The behavior of the animal is directed according to a field where its current position, its direction, and the obstacle are all given all at once, in an absolute survey. This involves the broad field of consciousness. To explain the properties of the field of consciousness by those of a hypothetical cortical field governed solely by the laws of molar dynamics is obviously a false solution. The animal, having accidentally entered the trap of an impasse, can turn back by momentarily turning its back on its goal, whereas the effect of molar dynamics would indefinitely keep it prisoner as. The water in the ascending branch of a siphon pipe can also go in a direction opposite to its final arrival point. But this is because the two water columns are in instantaneous equilibrium. The animal, on the other hand, balances not pure forces, but some means actions according to their direction relative. The direction, the meaning of an action relative to the goal, can then dominate the vectorial sense of the momentary move. The goal set is not fully materialized even when the animal is in an impasse trap from which it cannot materially escape. The goal set nevertheless manifests itself objectively through repeated efforts and subjectively through anxiety. The homeostat constructed by Dr. Ashby, which gropes around in order to correct a faulty assembly, cannot, however, get out of a dynamic impasse. It does not avoid dead ends. If the detour carried out in advance by the animal in its field of conscious behavior, before being carried out in its geographic, were only the projection of a cerebral homeostatic equilibrium, the animal should be as calm when it has fallen into an impasse trap as when it has reached its goal, as calm as the homeostat at a dead end. However, in microphysics, there is a phenomenon that constitutes a fourth kind of detour. The most well-known case is the tunnel effect, or Gamow effect, but it is very general. Despite a quote-unquote potential barrier, analogous to the rim around a well, and located at a quote-unquote height, such that it would indefinitely prevent the exit of a particle if it were similar to the particles of classical physics, the microphysical quote-unquote particle has a certain number of chances to exit, and a certain proportion of exits actually occur. It cannot be a question here of invoking a kind of siphon or slide or elastic link according to any guidance to explain the crossing of the barrier. The particle does not follow a representable trajectory step by step like molecules or water molecule in a pipe. The forcing of the barrier is excluded by the quote-unquote more dynamic situation, but wave models make it possible to understand the tunnel effect, since waves of probability of the particle's presence can bypass or pass through a potential barrier. Although the microphysical detour does not resemble the conscious detour, at least in the current state of scientific conceptions, it is nonetheless much closer to it than the others. It is characteristic that physicists cannot avoid using terms borrowed from psychology to characterize the microphysical. The particle, through the probability waves that constitute it, quote, explores space, unquote, instead of simply describing a trajectory. It is, quote unquote, potentially present in a whole domain of probability. Whereas the classical particle goes nowhere, and the end of its movement is simply the result of preceding elementary movements. The microphysical particle, quote, takes into account the, quote, intrinsic energetic legitimacy, unquote, the final state, and integrates the, quote unquote, means to achieve it into a unitary action where time as well as space seems to be surveyed, as in a consciously operated and calculated detour. The microphysical action, like the psychological action, seems to take place against a background of utopia and uchronia, a background of, unquote, otherwise. Its actuality is surrounded by, quote, glimpsed possibilities. Yeah, so I guess the basic point is that he gives these three examples of pseudo detours where some mass of elements as a mass, as opposed to a kind of integrated unit which would have this property of auto survey, is just guided by physical laws. He later compares this to like a crowd of people walking through a tunnel. So even if like the water molecules, perhaps for Ruyer, are not molar phenomena themselves like this, as a group, there's no absolute survey or feedback with this hypergeometric dimension. And then in the cases of genuine detour, as in the example of the animal that encounters an obstacle, the animal has this absolute survey of kind of where it has been, where it is trying to go, and the relation of the obstacle to its goal, and this sort of tension created by the obstacle for the animal kind of gives rise to this need to invent a solution to the problem posed by, the rock or whatever it is that's blocking its path. So yeah, as I understand it, what differentiates pseudo detour from detour is this absolute survey, but then also, and I don't know if he considers it part of the survey or a result of the survey, but these kind of glimpsed possibilities, or what he calls utopia or uchronia, these, I guess, virtual forms or solutions which are not present, but are sort of felt as things that need to be made present by the surveying consciousness.
Yeah, on his book on psychobiology, he distinguishes between these sort of intrinsic forms, so these absolute survey type of forms where there's this sort of the form exists for itself, if you want to use sort of Hegelian language. So like a biological organism is not just a sort of entity that we as observers sort of attribute a unity and a form to, but the biological organism sort of treats itself as this unity, as this form, and of course, this is the sort of like the one of the sort of peculiar theses that Ruyer proposes is that these microphysical entities are also these intrinsic forms. So an electron also sort of like treats itself as an electron, as this unity, as this entity that has a certain form. And then he distinguishes these intrinsic forms from like these kind of ensembles or aggregations of entities. So like the sort of stereotypical example you could pick for this would be just a pile of sand. The pile of sand is not sort of treating itself as a pile of sand, and each grain of sand is just sort of interacting with the neighboring grains of sand in this simple mechanical way, and has no sort of it doesn't make any difference to the grain of sand whether it's part of a pile or just interacting with this other grain of sand next to it. It just sort of responds to its neighbors in exactly the same way. And so the sort of sequence of examples that he gives here, like these water molecules, for example, flowing through a pipe. Given the layout of the pipe, you can sort of bring about the movement of water molecules against the direction of gravity, for example, through like pressure or just sort of the general like sort of hydrodynamic principles. But the water molecule doesn't sort of care in sort of a intrinsic sense, whether it's flowing according, in sort of conjunction with the direction of gravity or against the direction of gravity. It just sort of responds to the interactions with neighboring water molecules and the molecules that make up the walls of the pipe. It just sort of goes where it's being pushed by the different forces. Whereas in the case of this, these microphysical particles that can sort of tunnel through the potential barrier, he suggests that this is already something different than just the water molecules being pushed and pulled, or sort of just being pushed by the other water molecules and the walls of the pipe, in the sense that the sort of trajectory of the electron in this microphysical system depends not just on interactions with what is next to the electron, but also with sort of where the electron is capable of going. That like the system can develop only in certain ways. The electron has to end up in a certain state and not in some other state, and so because of this, the electron can sort of pass through this potential barrier that in a sort of classical system would block it from getting to the end state where it is capable of ending up. For Ruyer, the electron case is closer to the case of the animal, for example, that doesn't just sort of bang up against the detour and stop because it can't go any further, the way that like a water molecule would. It's a very different way of sort of carving up the world, that like electrons and animals are more like each other than, say, the animal is like the pile of sand. The pile of sand or the water flowing through a pipe are these sort of aggregates where each sort of element, like the water molecule or the grain of sand, is just sort of responding to the way it's being pushed by the neighboring elements, and then the sort of overall behavior is a kind of like statistical aggregate of what each grain of sand is doing or what each water molecule is doing, whereas the animal or the electron is a kind of intrinsic form that is not reducible to the behavior of some sort of sub parts that would sort of bring about that overall behavior.
So the sand molecule being in itself, right? And this being in itselfness is for another, right? That is like the pipe. right? So this this detour, right, is at least a current state of a scientific conception, right? It is a it is nonetheless a some kind of like a closer a closer to it than like the others, right? Like it's kind of like a a molecule, right? And like every molecule is kind of like determined, to move in itselfness in the others, right? The others in plural, I guess, right? So so the when you said like the neutrons, right? I don't know, the intrinsic, or let's I name it. I don't know if it's intrinsic energetic legitimacy, right? Of the final stage, right? What is this means to achieve it, right? What is this mean, like, to this unitary action, right? To this kind of like the detour, I guess, right? So if that makes sense, like the microphysical action, I guess.
Yeah, I mean this is so he's writing in, I guess, 1950s, and working with like 1950s science, or 1950s physics more specifically. But I think even today there's still a lot of uncertainty about what exactly is going on in this kind of setup. So we can say that like there's a certain probability that an electron in this arrangement will end up in state A, and then a certain probability it'll end up in state B, or whatever sort of number of states we have that are possible for this electron. But we don't really have a good model for what happens between the start of the sort of experiment or the process, and then the endpoint where the electron is in state A or B. So there are certain models of quantum mechanics that do involve something like a trajectory where there would be a sort of path from the starting point to the end point. But other, like the more sort of mainstream models of quantum mechanics involve a kind of there's no trajectory where the electron sort of goes between the starting point and the end point. There's a sort of like non-spatial, or like, yeah, it's hard to exactly express what it's supposed to be, what this model is supposed to be depicting, but the electron just sort of goes from the starting point to the end state, and there's no like trajectory in space between those 2 points. So yeah, it's still very sort of up in the air in contemporary quantum mechanics, as far as I know. But yeah, so for Ruyer, the electron sort of reaching its end state, or the one of these possible end states, is closer to the animal that sort of navigates around the detour than it is to like the stream that flows around a rock. It's obviously not exactly the same. He's not sort of supposing that the electron has a little picture of what it's trying to do, and trying to get to this end state in its electron head. But it's more analogous to that than it is to the water flowing around the rock.
Yeah, because I don't want to have a picture thinking, right, of this operation. Like, if we able to conceptualize this without intuition, our picture for Stalin would be very good. But I guess.
Yeah. Okay, so I think we can go on to the next bit. I'm gonna have to leave fairly soon, so maybe I'll just read the next one and then we can discuss, and then we'll stop there.
Okay.
Okay, so I think we were at
page 108.
Yeah.
In
Yeah,
any
so I think we're in any case. Yeah. Okay, I'll read the next bit. In any case, the microphysical detour and the conscious detour are clearly related. They both involve true and individualized actions. Other types of detours are degraded cases which only appear through the multiplicity of individual actions, whether they are conscious individuals or microphysical ones. A crowd channeled in the corridors of the metro or in the streets of a city hardly differs, as far as its capacity for detour is concerned, from a crowd of water molecules channeled in a pipe. It also stupidly hits an obstacle that accidentally blocks its path. Each of the individuals that compose it calculates their walk through conscious survey relative to the immediately neighboring individuals, but the absence of a general survey degrades the behavior of the crowd as such. In any case, the channeling connection, liaison, and the structuring it applies to amorphous crowds cannot, without contradiction, serve to explain the elementary connections and structuring that emerge de novo. Standing waves, which constitute the electronic layers of the atom, cannot again be like waves in a sound pipe. Electrons or associated waves do not circulate between solid walls. A pipe or a system of conductive slides preserves information. It delays its degradation or materializes information previously created by a field of consciousness for the use of a blind crowd. The siphon and U-shaped piping was built by an engineer. Similarly, the road or railway that circumvents obstacles winds its way according to the slope or passes through bridges and tunnels. The few natural pipelines that can be cited, artesian wells, intermittent springs, natural bridges, etc., are of little importance and are truly lusus naturae. It is obviously necessary for a certain primary quote-unquote linearization of causality, or rather of individual activity, to occur directly by surveying and calculating possibilities, so that secondary linearizations by tubes or slides are conceivable without contradiction or infinite regress. If the entire domain of microphysics is precisely the area where, quote, it is necessary to stop, unquote, and where, quote, one can stop, unquote, it is because microphysical individualities are sources of information and structuring as primary as a field of consciousness. Structuring bonds, liaison, cannot again be explained by pipelines or walls. Otherwise, another wall or rail would be needed to quote-unquote linearize the wall or rail, and so on indefinitely. What prevents us from grasping this obvious fact is that at our scale, the movements of bodies or particles appear to us to be naturally channeled by the material consistency of the moving bodies. But movement, according to wave mechanics, is always propagation and not material transport. The movement of a supposedly substantial moving body is only the secondary appearance of an electrical luminous propagation and, more deeply, of a system of probability waves. A certain wave behavior must be defined before we know what is propagating and what is moving. The manner of propagating is more fundamental than, quote, the body moving in space, unquote. Therefore, this propagation of information, which is essentially movement, must channel itself, must indent its own connections in its own field. Without this self-channeling by indention, that is, by participation in a chosen type or possibility among possibilities and non-actualities, nothing could exist in our space. Everything would be lost in absolute homogeneity or zero information. In the microphysical domains, binding information must appear. It cannot simply be conducted. It appears by epigenesis as organic or psychological differentiations appear. Let's stop here. So this is like basically his central argument that he just sort of repeats in various forms and in different contexts, this idea that you can only get so far with a machine, or what he's describing here as like a tube or a pipe or whatever. Like you have some sort of system that like limits the possible outcomes. The pipe makes the water flow in this specific direction and not other ones. You can't explain the pipe itself in terms of some like more abstract or more micro pipe, or you maybe you can go one or two steps or a certain number of steps in this direction. The functioning of the pipe is the result of some other sort of like micro pipe or whatever, or system of micro pipes. But you can't just keep doing that forever. That there isn't just this infinite turtles all the way down kind of sequence of pipes that is sort of responsible for the presence of the pipe at the sort of macro level that we observe. We have to at some point get to something that is not itself a pipe or a lever or a machine in this very general sense, that brings about this kind of limitation of possibilities or selection of one sort of outcome from this abstract set of possible outcomes. This sort of selection has to happen in this intrinsic way. There has to be something that just sort of has this absolute overview, this capacity to select one outcome from many possible ones. It just has that capacity intrinsically, and not as a result of being confined by a pipe or some sort of connection or machine. That's just sort of his like general argument that he's sort of applying to many different types of systems. And so this is like here in the case of the microphysical systems, these electrons and so on.
This reference that he makes to, as you were talking about, the participation in a chosen type or selection of possibility. I'm still trying to work out how the absolute survey relates to the kind of virtual forms or the, I guess, possibility space out of which certain possibilities can be actualized. Maybe, he gave in the last reading we did, he gave the example of the atom, which because of this tension between positive core charge and negative charge, and also the kind of behavior of the electrons in the valence shell gives rise to this, or has access somehow to this tendency to return to type, which I think is kind of the virtual in that case. And in that case, it seems like maybe the form could be understood as a sort of equilibrium state that the atom is seeking. So, maybe these systems of absolute survey have the ability to kind of seek their own, like in their own equilibrium. And then maybe in more complex systems, this familiar point and equilibrium itself can change. But yeah, the connection between those elements still.
Yeah, I mean, I don't think he gives us he's not sort of doing quantum mechanics, of course. He's a philosopher, not a physicist, so he's not sort of presenting us with an account of, how electrons work. He's just sort of taking accounts that are provided by physicists and sort of making a connection with, or making an analogy with the sort of psychological operation of going around a detour, for example. So I think he's not really telling us how an electron gets through a potential barrier, for example. He's not sort of aiming to do that. He's just sort of saying that this operation, or this process in which an electron tunnels through a potential barrier is analogous to the process of an animal getting around an obstacle or something like that. So it's more a sort of pointing to an analogy rather than sort of providing a model for how it's supposed to work. But yeah, I think it's interesting here that Ruyer is sort of pointing to this, like the sort of field aspect of quantum mechanics, because I think this is sort of early days for quantum field theory. At the time he's writing, it was still sort of in development. But yeah, this is like exactly how these kinds of things are presented in quantum field theory. That there are matter fields, and what we think of as like the movement of a particle through space is just propagation of a certain packet in that field across that. It's like a wave propagating in a field. So we think of like movement of a particle through space, or of a body through space, as a sort of like simple phenomenon that like it's just sort of obvious what we mean when we say that this particle moved from point A to point B over time X. But if you sort of think carefully about what exactly you're saying when you say that this particle moved from A to B, it turns out to be more complicated to explain. And you're saying something like the properties that we use to identify the particle were present at location A at the beginning of this time period, and then we're propagated through space. That this set of properties is sort of passing from this point A to this point B over time, and so you have like a trajectory of properties through this field, and this is like maybe a more fundamental description of what's going on than just saying this object was at point A and then passed through this path through space and ended up at point B. But so when you sort of pass to this more like sort of field description, it then becomes clear that you can't just sort of presuppose that this bundle of properties that we sort of ascribe to this object should all just sort of stick together in this way. That the fact that the electron has a certain charge at the outset of the process and is in this location, there's no sort of a priori, or we have to give an explanation for why that charge should sort of stay in that sort of one spatial location, or why it should sort of stay together and not just sort of diffuse throughout space. if everything is just this sort of excitations of the fields, then we have to sort of give an account for why this bundle of like field excitations is sort of stays together and moves in this one trajectory rather than just sort of doing any of millions of other things that you might imagine that it could do. And so then, yeah, so as he points out, the fact that we have this sort of predictable sort of development of these fields over time can't itself be explained in terms of like, a tube that the field has to, this wave in the field has to pass through, because then you would need to, explain this this tube in terms of some other set of fields and waves and so on, and like you're sort of doing the turtles all the way down type of explanation if you assume that the tubes and pipes or whatever are themselves explicable in terms of pipes. Okay, so yeah, I think we can stop here. I need to go have breakfast. So yeah, thanks everyone for coming out today. So yeah, next week we should be able to finish this chapter and start the next one.